Yeah, hi everyone. This is Aaron, and today I'm going to present to you how to containerize and deploy a Python application in a Python application. Basically, my main motivation for this talk was uh, as developers we tend to uh, write more of code and write uh, work more as a what do you say as a developer. uh, we try to fix code, but we don't give attention to CI/CD or the process in which our code is deployed. So this was the main motivation for my talk. uh, uh, yeah. My name is Aaron, and I'm into the DevOps field for about 4 years now. I've been working in Nokia Networks. Uh, uh, I'm currently working with Nokia Networks as well as an R&D engineer. I have 14 years of experience in the IT field. So, uh, Keeping it short, I would like to start my presentation by telling how containerization matters for Python apps. Containerization matters for any app to create and build images that can be replicated across environments. These are easy to store and they are easy to deploy. Uh, uh, when I say containerization, there might be set of folks who might have worked in the older version of Python or monolithic applications or not the microservices world. Uh, if the apps are not containerized, we definitely get issues like we have to set up the VM, we have to set up environment variables in the VM, we need to configure a lot of stuff in the VM. But as uh, as we progress over here, we'll see how simple it is to containerize an app. And these are the issues which will go away. The code works in my system, but it is not working in working in the production environment or the staging environment. Since the image will be same, the image used would be same in all the environments. The environment configurations will be very minimal, and we can just deploy and containerize apps faster. So this will help us uh, get a command over our product rather than uh, rather than the ops team and the development team fighting across on this is a code issue, this is a environment issue. Rather, the ops team and the development team can work together uh, as a DevOps unit. So overview of the tools we'll use. So basically we'll be uh, using the Docker desktop, and I have used the Python code, and I have uh, I have Docker desktop set up here, uh, uh, Python setup here in my machine, Python 3, where I have a sample project, right? And then I uh, have the Docker itself installed. So these are the tools: Visual Studio Code, the integrated development environment for Python code. So these are the basic tools which we'll be requiring for this session as such. So first thing is preparing the Python app. We'll follow a code structure like this. Uh, as you can see here, uh, we would we would be following a code structure like uh, the the requirements.txt would be there, Dockerfile will be there, and all the Python files will be here. in the src folder. I haven't uh, configured that structure yet, but we would have a src and a tests folder under our Python project, right? Which will the test folder will run the test. SRC folders will contain all the Python files which will be doing the set of jobs. So what we are going to essentially do here is we are going to create the Docker file in the root folder, and as we can see, we would be breaking down the Docker file. So first step is so to create a Docker file is nothing but uh, a read-only template, right? From which containers can be created, right? What we do in Docker is, first of all, we have the from instruction. We'll create a Python. We'll take the Python 3.11 slim version of the uh, Python app. So this is basically an image which will be in Docker Hub present, and Docker Hub is nothing but uh, a repository tool. Are you all able to hear me now?
Yes.
Yeah, okay, okay, fine. Uh, this is an older message now. Uh, yeah, so what we'll be doing is we are copying all the folders from the app directory. We are creating a working directory. Uh, Docker Hub, as I was showing you, Docker Hub. Docker Hub is a image repository by Docker, but we can have a private registries like Harbor. Uh, we can have Nexus, so we can have multiple repositories. Earlier, Docker used to provide free space to store the repositories and pull pull the repositories, but afterwards it limited the number of times we can download the repos and uh, uh, push the uh, push to the repository. So people started using private registry like Harbor. Uh, so here, if you can see, if we search for Python, we'll get the official image for Python. That's what I have used in my Docker file. So if you see Python Docker official images, yeah, over here, different versions of uh, different versions are there. The latest version being 3.15. So the slim versions are like an alpine images. Alpine images is nothing but bare minimum what is required to run a Docker container. So what we are trying to do over here is, instead of starting from a scratch container, we are taking a slim image of 3.11 version and 3.11 slim, and then we are creating a work directory called as slash app inside the container, and then we are copying whatever is there in the build context. We are copying it to the environment, and then we are exposing the 8083 port, and then we are running command python and server.py. So this is uh, the simplest form of Docker file which we can write. We have from instruction, we have work directory, we have copy and add instruction, we have expose instruction, we have env instruction. Env is supposing if you want to set any environment variables, we use the env instruction. And we have cmd and entry point, this entry point commands. Cmd command will tell us how to start a server.py, right? Python file. And that's even entry point would do the same thing, but in cmd we can give multiple arguments along with the python server.py, right? Whereas in entry point, and we will have to we can override one command itself. So is choosing of the base image. So whichever version our python is running on, based on that we'll choose our base image. Base image is nothing but 3.11 slim, whatever I'm showing you in this docker file. Choosing the installing dependencies, copying the source code, and setting the entry point or the cmd command. Cmd command is to uh, start the python app. And copying the source code, as you know, whatever the source code is which is present for the all the python files which are present in our system, it should run in the container so that we get a meaningful output. So building and running the container, I will build this px store uh, project locally. So this is the docker build command which is reading from the docker file. If we name the docker file as docker file like this, then it will read the docker file from the folder which we are in currently, and it will dot initiates that it's the current build context. So next, what we can do is docker run the app thing. Uh, so we had given the name of our application, tag name of our application as app. uh, so there is a syntax error. Yeah, I'll just build it again for you. There were some errors in the app due to which the docker app is not running. So the Docker engine, we can so in the Docker engine, we can see our containers running. If you can see, uh, we have the app running as nostalgic was neck. That is basically they have given some random names for the container. It is running from 46 seconds. Now, if I go and hit localhost 8083, I can see the localhost 8083. We can see that. Okay, so there's one error in what I have done. We had to give the uh, port number as 8083. I had not given that. Docker run app. So we can run it in detached mode, uh, so that the command line does not come. Let me just clear the console for you. Yeah. So now if we hit the localhost 8083, we should see the app running. Yeah. So this, as we can see, it's showing key not found. Uh, this is basically a server app. Uh, Postman would have, we can add a key and uh, images. So we can check the logs of the container over here. See, this is the running one. So we can see the logs, starting server on port 8083. Currently, the page is not found because there are no this one. There's no key. Key as, let me give key as Aaron. It might come as same thing. We'll have to post it. I will just open the Postman. As you just containerize the any application, you need to follow only a set of rules. Like you need a base image, you need a uh, you need a uh, directory app, and we just need to basically call uh, run the Docker file, and we just need to create a Docker file which will take maximum up to maybe for a very difficult container, maybe it might take up to 1 day or 2 days, but the code issues will go off, and we can see that our applications will work as simple uh, running the Docker container. So what we can do is, I'll go to the next slide once. Okay, pushing to the Docker Hub. If we want to push this image to the Docker Hub, we can just go to the Docker desktop. We can even do it via the command line. We can do Docker push -u -p, give the username and password, and we can push it via the command line as well. Well, but here, if I go to images, there is an app image. I can just uh, push to hub. So earlier there was like in Windows we couldn't use it, but now after the Docker desktop recent versions and all, we can use these things in the Windows laptop as well. So I'll go to the Docker Hub once to see whether to verify whether my uh, meanwhile, y'all, if y'all have any questions, y'all can just ask me, because I think I'm running out of time. If I'm not sure, but I could be running out of time. Yeah, Michael. So uh, I'm done with my presentation, but if there are any questions, I can take it up. Meanwhile, I just wanted to show the Docker push code.
Okay, then let's so
To
we
summarize,
yeah, please summarize. Yeah.
yeah. So uh, basically, what we have done here is uh, we have done a hands-on on. Uh, we have done a hands-on on how to create a Docker file. I'll, we have uh, learned how to create a Docker file from scratch, or how to create a Docker file from an Alpine image. Once we have created the Docker file, we build it using the Docker build command, and then we run it using the Docker run command. And once all this is set up, we can see that our app is running. So any environmental issues usually do not happen in this kind of containerized environments. And because we set the env flags in the Docker file. Well, obviously I didn't show that env part of it, but it is We can set the environment arguments by using the env command.